All right, today we're going to be talking about parallel lines and the angles that are formed when they are cut by another line called a transversal. So a transversal is a line that intersects two or more lines. In the figures below, here we have line M. Oh, that is a thick highlighter. We have line M, we have line N, and then our transversal will be this line that intersects those two lines. So in the figure below, M and N are parallel and they're cut by transversal L. And you'll notice that there are 8 angles formed by that intersection, and they are actually numbered for you 1 through 8. They all have special relationships and names based on their relationships with each other. So the first one is called alternate interior angles. It's exactly what it sounds like. It says that they're on opposite sides of the transversal, hence the word alternate, and they're in between the parallel lines, so they're like on the inside. You can think of this as being like the interior, and you can think of this as being like the exterior. So the interior angles are 3, 4, 5, and 6. And so the alternate interior angles would be like 3 and 6 or 4 and 5. So there's an example. Alternate exterior angles would be on different sides of the transversal, hence the word alternate, right? But on the outside. So maybe like 2 and then another one that's outside, but on the opposite side would be 7, or 1 and 8 would be the other alternate exterior angles. But here's one example. Then we have same side interior angles, exactly what it sounds like there. Same side means on the same side of the transversal and both on the inside. So like 4 and 6 would be same side interior, or 3 and 5. Same side exterior angle, you probably know exactly what that's going to be, on the same side, but both on the outside, like 1 and 7 or 2 and 8. And then let's erase some of this just for my own sanity here. I thought it was going to erase the actual notes. Thank goodness it didn't. Okay, corresponding angles are same side of the transversal, 1 interior, 1 exterior, like 2 and 6, for example, would be corresponding angles. Or we could have another example, might be 3 and 7, because they're on the same side of the transversal, but 1 inside, 1 interior, and 1 exterior. Okay, now you're going to use a protractor to measure all the angles that are up here in this drawing. So in class, I gave everybody a protractor, and you guys went ahead and measured those. Well, now I'm in my classroom without any students, and I'm doing these notes, so let me grab a protractor because I actually can't remember, since we haven't actually done these notes yet together. I don't remember how big the angles are. So I have my protractor. I'm going to put this vertex right here in the little circle of my protractor. I'm going to line up line M with the line on my protractor, and then I probably am going to want to extend this, right? So it goes through a number on my protractor, and I can see that it is 55 degrees. So this is 55. And as I go through and I measure these with my protractor, all of these little ones are going to be 55. And as I continue measuring with my protractor, all of the obtuse angles, the big ones, are going to be 125. Oh, that is, I don't want that to look like a 0. 125 degrees. Okay, so then it says to use a protractor, and what do you notice? Use highlighters to show congruent angles. So let me highlight in yellow, oh goodness, all of the angles that are the same here. All of these are the same size, all of the acute ones. And then in pink, I'll highlight all of the obtuse angles, because all of the obtuse angles end up being equal. So they're asking you what you notice. So you can write things like, all of the acute angles are the same, or all of the obtuse angles are the same. Let me write that real quick. All acute are equal, all obtuse are equal, And then one other very important observation is that the sum of one acute and one obtuse is 180. This becomes very important as we're learning about parallel lines. So if that's true, that all of the obtuse angles are equal, without using a protractor, we know that every obtuse angle in this drawing is 135 because we knew that this one was 135. And we know that all the acute angles add up to 180 with that obtuse angle. So I can do like 180 minus 135 to find out that all the acute angles are 45. Now that just makes sense because I'll show you why it makes such good sense. This is a straight line. These two better add up to 180, right? Plus we know that vertical angles are equal. We've got all these things going on here. Okay, so if we look at that drawing and our definitions, we know that alternate interior angles like 3 and 6 in this picture up here, 3 and 6 are equal. Alternate exterior angles are also equal. Same side interior angles like 3 and 5 are supplementary. They add up to 180. Same side exterior, supplementary. And corresponding angles are like 2 and 6 are going to be equal. All right, so since we know all of that, you really don't even have to memorize the names as much as just knowing that if they're both acute, they're equal. If they're both obtuse, they're equal. And if you have one acute, one obtuse, they add up to 180. So in this picture, these two are both obtuse angles. Oh my goodness gracious. So those are equal. And we can write an equation. 3x is equal to x plus 80. And we're just going to solve it using all the steps we've learned about equations. So we have 2x equals 80. So when I divide both sides by 2, I get that x is 40. So it might ask you what's x, or it might ask you how big is the angle. So if they ask you what's x, which is what they're asking, then it's 40. But if they ask you how big is this angle, you just do 40 times 3 is 120. So the actual angle size is 120, and 40 plus 80 is 120. And they have to be the same, right? That's how we set up our equation. Okay, for the next example, we have that this acute angle here is 2x plus 12, and this obtuse angle here is 4x. So these are not equal to each other. In fact, one is an obtuse, one is acute. So together they make 180. So we're either going to set them equal to each other or the sum is 180. So let's go ahead and solve this using the steps we know about equations. We're going to combine like terms on the same side, and now we just have a two-step equation. So we'll subtract 12. And we get 168 over here. And when we divide by 6, 6 goes into 16 twice, and then 48. So 28 would be how big x is. If we wanted to know how big is this angle right here, we would do 28 times 4, and we would get 112. We could also do 28 times 2 there to get 56, and then 56 plus 12 would give us 68. So this one, let me get a different color. This angle right here is 68, and this angle right here is 112, and they should add up to 180, right? Because that's how we did our equation. The sum is 180. All right, you guys, thanks so much for watching.